Here we go. Let's do a problem from the 1994 AP Calculus exam. And this problem also would be calculator inactive because they did not allow, well, calculators back then, or they just didn't have them in abundance. So, circle is inscribed in a square shown in the figure below. So when I say inscribed, basically this circle is stuck inside this square and the circumference of the circle is increasing at a constant rate of 6 inches per second. When you read stuff like that, I just like to go ahead and start writing. That's what I do anyway. So let's just go ahead and start saying that the circumference, the dt, is 6 inches per second. We know that much. As the circle expands, the square expands to maintain the condition of tangency. What? Okay, so tangents, you've heard of this before, but this is a slightly different concept. Tangents touch at one point locally, and so there is a one specific point here where the circle touches the square, and here, and here, and here. It looks flattish, but it's not. And so as this circle increases in circumference at 6 inches per second, the square increases in size as well. And so basically this entire shape maintains its intactness. It remains intact. So part A, which I will do here, find the rate at which the perimeter of the square is increasing. Well, there we go. Let's just keep going. I want to find the perimeter of the square rate and indicate units of measure. And this is part A, okay? So let's kind of jump in and figure out what we know and what we don't know. We're dealing with the perimeter of a square, and the perimeter of a square is, well, 4 times the length of a side. Okay, so you could say that the perimeter is 4 times the length of a side, and you would not be wrong. And you might say, well, then what's the length of the side? I don't know what it is. And don't panic. Let's just start thinking our way through this. We also have a radius. The radius, I'm going to draw it this way. There's our radius. The radius is going to determine the size of the circle, which also determines the size of the square, right? So the circle's getting bigger, so the square gets bigger. And so what we really have is the circumference of a circle. Okay, see this? They gave us dc dt for a reason. There we go. We have that. And we're going to do something with that. Now, I never finished this over here. I'm going to go ahead and finish that. It's helpful if we don't say, oh, well, the perimeter is 4 times the length of a side. Okay, yeah. But you know how long a side is? Do you? It's r plus r. The diameter, 2 radii, make a side. So this is r and r and r and r, 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 r. So it's 4 times 2r, which you could go ahead and put 8r. Okay? I'm using r because we're dealing with the length of a circle, the length of the radius of the circle. Okay? I want to take the derivative of this. I know I need to, so let's do it. dp dt equals, okay, the derivative of 8r is 8 dr dt. They're asking us to find the rate of change of the perimeter. I still don't know dr dt. Let's find it. Let's find it. So let's jump over here and, well, find it. So dc dt equals, let's see, the derivative of 2 pi r would be 2 pi dr dt. We know this is 6, and we'll find dr dt by dividing by 2 pi. That gives us 6 over 2, so 3, and then pi in the denominator. Okay. You may want to grab a calculator and find it. I'm not, actually. I'm going to leave it like this because it's 1994, which I remember that year. I didn't take calculus that year, but I remember that year. And there it is. Now, let's go a little further. In today's context, we could leave it like this, but let's go a little further. That would be 24 over pi, and then it says, indicate units of measure. Okay, we just found the rate of change of the perimeter with respect to time. Okay, perimeter is a linear length. It's not square units, it's not cubic units, it's not area, it's not volume, it's perimeter. So it's inches per second. And there's part A. Let's do part B. Things get a little tricky here. Let's just start listing some things. At the instant when the area of the circle is 27 pi square inches, stop right there. The area of the circle, let's switch to blue, I feel like it. So the area is 27 pi square inches. Find the rate of increase of the area enclosed between the circle and the square. Indicate units of measure. All right, already we've run into a problem. We have two different areas. I'm holding up 3 fingers. Okay, we have 3 different areas. We have the area of the circle. We have the area of the square. And we have the area of the enclosed space in between the two. Let's clarify what I mean by that. Where's my other pen? It's in my pocket. Okay. When they say find the rate of the increase of the area enclosed between the two, they're talking about this little thing right here, a little highlighter attachment on my pen. I don't know why I felt the need to brag about the nerdy things I carry in my pockets, but there you go. This is the area of the enclosed region. And if you don't highlight, it's totally okay. If you don't have nerdy things you carry in your pockets, it's okay. There we go. Area of the circle. And just to clarify what's actually happening here, I'm defining some variables, sort of. So AC is the area of circle. You don't have to write all this, but it's going to come in handy later. AS is the area of the square, and AE is the area enclosed between the circle and the square. Okay, just writing some things out so you know what all this is, okay? Let's move on. Okay, all we really know is this, and then a few other things that they told us up here. Like we know the rate of change of the circumference, we know the rate of change of the perimeter now, we know the rate of change of the radius. All this information carries us forward. I'm not going to write it all again. But I need to know a formula for this because here's what they're asking. Find the rate of increase in the area enclosed. That's what they want to know. So before I really go any further and I list this and I find that and all that, and I may not even need these things, like I may not even need to know this at all. But before I do anything else, I need a formula that tells me this area. Let's find it. Let's switch colors. It's for fun. The area enclosed between the two figures is going to be, and I'm not even going to use like a formula much yet. It would be the area of the square minus the area of the circle. So I mean that's a formula, but it doesn't tell me much. So now let's go a little bit further. So the area that's enclosed, the little highlighted area, if you have nerd things you carry in your pockets, the area that enclosed is the area of the square. Okay, what's the area of a square? It's the length of a side, well, squared times itself, and the length of a side is 2r. So 2r squared. What's the area of a circle? Pi r squared. Okay? Still good? I hope so. Let's clean this up a little bit more before we keep going. That's 4 pi. No, it's not. It's 4r squared. I apologize. 4r squared minus pi r squared. And now they're asking us for this rate of change. Find the rate of increase in the area enclosed between the circle and the square. So let's do it. Let's find it. dA enclosed over dt equals, the derivative of this would be 8r, I keep wanting to write a pi, dr dt, minus 2 pi r dr dt. And we are going to find out what we don't know as we keep moving. So 8 times the radius. I don't know the radius. Man, I don't know the radius. Okay, we'll get over it. Let's keep moving. And as I do this, actually, I'm going to pretend like it's 1992 and I don't have a calculator because I think it's a good idea. It's a good idea to time travel. It's fun. I do it all the time. All right, I don't know the radius, but I can find it out. And here's how I'm going to do it. I'm going to go up here in this little space. If the area is 27 pi, and the area of a circle is 27 pi, and the area of a circle is pi times r squared, then 27 pi equals pi r squared. So 27 equals r squared divided by pi. And so we take the square root of 27. 27 is 9 times 3. Square root of 9 is 3. Square root of 3 is irrational. There's your radius. We just found it. So now we know our radius. Disgusting though it may be, that's it. dr dt is 3 over pi minus 2 pi r. What's r? 3 square root of 3. dr dt, that's 3 over pi. Okay, on today's exam, we could leave it like this, but we're not going to today. Let's keep going. It's a mess, isn't it? It is a mess, boys and girls, I'm telling you. All kinds of messy. All right, 24 times 3 is 72. 72 square root of 3 over pi. There's your first term. Here's your second term. Pi cancels with pi. Lucky us. Okay, so 2 times 3 is 6. 6 times 3 is 18. So minus 18 square root of 3. No pi's on that. There's our answer. Indicate units of measure. You'll lose points if you don't. All this is, and I'm going to put it in parentheses because the units will apply to the entire thing. We're dealing with the area of something, so it's square inches. And we're dealing with the rate of that area, so it's square inches per